Hello students, in this video I will go through exercise U5A07C where I will be applying concepts related to angles of elevation and depression. Alright, question number 5. Oh, and by the way, these questions are taken directly out of the Envision text from page 377 to 379. Alright, question number 5. A person rides a glass elevator in a hotel lobby. As the elevator goes up, how does the angle of depression to a fixed point on the lobby floor change? So let's say this is the glass elevator and it's going up, right? Yes, it is going up. And how does the angle of depression to a fixed point on the lobby floor change? So the lobby floor is here. The angle of depression, as a result, is going to increase. Right? Can you imagine this? If you go up even further, theta will get larger. Angle of depression will get larger. Say if the elevator was there, the angle of depression would be very, very small. Okay. A person observes that the top of a radio antenna at an angle of elevation of 5 degrees. After getting 1 mile closer to the antenna, the angle of elevation is 10 degrees. How tall is the antenna to the nearest tenth of a foot? So let's draw the situation. A person observes the top of a radio antenna at an angle of elevation of 5 degrees. So this is the top of the radio tower, and this is 5 degrees, angle of elevation. And after getting 1 mile closer to the antenna, the angle of elevation is now 10 degrees. And this distance here is 1. How tall is the antenna to the nearest tenth of a foot? So, in other words, we want to find out what this height is. This is actually a pretty nice problem. So there are a couple of unknowns here. We have actually no idea what h is. We have no idea what is this length over here either. We don't know what that is. So I'm going to call that x. And what we can say is, what can we say? That h over x is equal to tangent of 10, right? H over 1 plus x is equal to tangent of 5. So what I can do from here is I can solve for h in terms of x from the first equation there. So h will equal to tangent of 10. And since h is equal to tangent of 10, I can then substitute that, h is equal to tangent of 10x. I can then take this and substitute into the second equation. I can then say tangent of 10x over 1 plus x is equal to tangent of 5. And this now becomes an algebra problem and less of a geometry problem. So I'm going to cross multiply both sides by 1 plus x, and I'll end up with tangent of 10x is equal to tangent of 5 times 1 plus x. I will now distribute the tangent of 5. So tangent of 5x is equal to tangent of 10 times x. I'm going to bring over everything that has an x in it to the other side. And if I do, I'll end up with tangent of 10x minus tangent of 5x is equal to tangent of 5. I'm going to factor out an x. Tangent of 10 minus tangent of 5 is equal to tangent of 5. Divide both sides by tan 5 minus tan 10. I'll end up with x is equal to tangent of 5 all over tangent of 10 minus tangent of 5. So once I get x, I can then get h. So x will equal to tangent 5 divided by tan 10 minus tan 5. I'm going to punch that into the calculator. And that would be 0.984. Hold on. Right. So that would be 0.984. That's x. And once I know x, I can then get h. Since h is equal to tan 10 times x, h will therefore equal to 0.984 times tangent of 10. So 0.984 times tangent of 10. And that would be 0.1735. Or 0.174. And the question says here, how tall is the antenna to the nearest tenth of a foot? Boy, they really went out here. So this right now is in miles. So I got to convert this into feet. Okay, so 0.174. So h is equal to 0.174 miles. But this is equivalent to how many feet? I need to convert that. A mile is how many feet? I actually don't know. So let me type that into the Google. So 1 mile and feet is 5,280. Of course it is. So we're going to multiply this by 5,280. So I want to go to my calculator times 5280, and that would be 916 feet. It says to the nearest foot. Boy, that was a tough one. I did not expect that. Okay. So question number 7. Triangle ABC has AB is equal to 13. AC is equal to 15, and angle A is equal to 59. What is the area of triangle to the nearest tenth? So here, so A, B, and AC. AC is 15, AB is 13, and the angle in between is 59, and I have no idea what this is. Okay, so then you're asked to find out what is the area here. So this is actually another tough one. However, you do have all the tools at your disposal. It's just a matter of being able to put this together. So I know that the area of a triangle is base times height. So I'm going to call this side here H. Okay, so how do I find out what H is? Well, I need to use sine, cosine, tangent. So I know that H is opposite of 59, and 13 is hypotenuse. So therefore I can say H over 13 is equal to sine of 59, or H is equal to 13 times sine of 59. Since H is equal to 13 sine of 59 and area is equal to base times height, 1/2 base times height, the base is 15, So I can say 1/2 of 15 times 13 sine 59. And all I have to do is just enter that into the calculator. So 0.5 times 15 times 13 times sine of 59. 83.57. So this is 83.6 because I need to round to the nearest tenth. And there's no units here, so my final answer does not need to have units. Okay. Triangle DEF has 13 and DE equal to 13, DF is equal to 15, and EF is equal to 14. So let me do this. So DEF, not drawn a scale. DE is 13, DF is 15, and EF is 14. Okay. What is the area of the triangle to the nearest tenth? Okay, so in order for us to do this, you actually do not have enough information to do this, or at least you don't know enough yet. You have to know something called the Law of Cosines. So actually, I'm going to skip this problem. So I want to put an X here. And I want to make changes to the original document. All right. A temporary pen for cattle is built using 10-foot sections of fence arranged in a triangle. All right, so I have 10, 10, 10. Okay. One side of the pen has 4 sections, one has 5, and the last has 6. So we break this up into 4. Whoops. And then this one into 5. 1, 2, 3, 4, 5. And the last one into 6. Okay. What is the area enclosed by the pen? One side of the pen has 4 sections. What is the area? What was the point of them telling you this? They were using 10-foot sections. Oh, no. Okay, so the 10-foot sections is not... So one of them is 3, 4, 5, and 6. So that means this is 40, 50, and 60, because each of the sections are 10 feet apiece. So misinterpretation there. And again, this question requires law of cosine, so I'm going to skip that. You don't know that. Okay, question number 15. What is the angle of elevation to a building 1,000 meters away that is 300 meters high? All right, this is something you can do. All right, so angle of elevation is this guy right here, and a building 1,000 meters away, so this is 1,000, and 300 meters high, so that's 300 meters. So in other words, opposite over adjacent, that's tangent. Tangent of theta is equal to 300 over 1,000. So theta is equal to the inverse tan of 3/10. And we need to... What is the angle of elevation to a building 1,000 meters away? That is 300 meters. It doesn't ask you to round to anything in particular, but this is what it is. So I'm going to enter that into the calculator. So arctan of 3/10, 16.7 degrees. To what angle of depression should the security camera be adjusted in order to have the lens aimed at point P on the ground? So, to what angle of depression should the security camera be adjusted? So let's say I have a security camera here, and in order to have the lens aimed at point P on the ground. I don't follow this question because there's no diagram that comes with this. Oh, it says see example 2. So you know what? Skip. You're not going to do that because there's not enough information here in that document. So number 18. Libby's eyes are 5 feet above the ground, and the angle of elevation of her line of sight to the top of the monument is 74 degrees. Okay, I want to draw not a 3D diagram like they have there, but a 2D one. So this is 5, 5, 5. And this is 74 degrees. And how far is she from the monument? So in other words, they're looking for this. We're calling that x. So in that case, then we're going to call this is tangent. So tangent of 74 is equal to 555 over x. Let's cross multiply. X is equal to 555 over tangent of 74. We're going to enter that into the calculator. That's 159.14. How far is she from the monument? So to the near, it doesn't say round to anything, so I want to round to the nearest feet. So it's 159 feet. Okay. A research submarine dives at a speed of 100 feet per minute directly toward the research lab. Okay. How long will it take for the submarine to reach the lab from the surface of the ocean to the nearest tenth of a minute? Okay, so we're traveling at 100 feet per minute. Let's figure out what is the distance that the submarine has to travel to begin with, right? So this is 100, or actually 1,000. And this is 20, and we're looking for the hypotenuse here. So 1,000 is opposite of 20, so we're going to be using sine. So 1,000 over h is equal to sine of 20. So h is equal to 1,000 over sine of 20. This is the distance. And we're going to punch that into the calculator. 1,000 divided by sine of 20, that would be 2923.8. feet. So if the sub is traveling at 100 feet per minute, so we're going to multiply, or actually we're going to divide this by 100 then. 2923.8 over 100, right? Feet divided by feet per minute. We're going to end up with minutes at the end. Divide by 100. That would be 29.23 minutes. To the nearest tenth of a minute, 29.2 minutes. All right. And over here, Benito aims for the center of the target from a distance of 70 meters. If Benito shoots an arrow at 0.055 degree angle of depression below the center, will he hit the yellow circle? So let's draw this out. Benito is 70 meters away, and he's going to be aiming at 0.055 angle of depression below the center. And the question is, will he be able to hit the yellow, which is 12.2 centimeters? So this 70 meters, okay, let's figure out, well, let's convert this into centimeters. So we're going to multiply 70 by 100, and that would be 7,000 centimeters then. Let's figure out what this height is. So h over 7,000 is equal to tangent of 0.055. So we're going to punch that in. 1,000 times tangent of 0.055. That would be 0.9599. Did I do that correctly here? Let me see. 1,000 tangent 0.055. Yep. 0.959 cm. So if the yellow is 12.2 centimeters, right? So that means the whole thing, this is the half of that would be 6.1 centimeters. So Benito will be able to hit the yellow. Yes. Benito will hit the yellow section. How do you spell Benito? Benito. How do you spell your name? B-E. Benito. Benito will hit the yellow section of the target. Okay. And last question here. Ramona is climbing a hill with a 10-degree incline and wants to know the height of the rock mountain. Okay. 10-degree incline. Is climbing a hill with a 10-degree incline. Okay. And wants to know the height of the rock mountain. She walks 100 feet, okay, up the hill and uses a clinometer to measure the angle of elevation to the top of the formation. She then walks another 229.4 feet to the top of the hill. To the top of the hill, 229.4 feet to the top of the hill. What is the height of the rock formation? So the incline that's 10 degrees. This is 10 and this is 100. Okay. And uses a clinometer to measure the angle of elevation to the top of the formation there. And the top of the formation is going to be 22 degrees. Okay. And she then walks another 229 feet to the top of the hill. So this information about her walking another 229.4 feet to the top of the hill, that's excess information. You actually don't need that. So so what we can do, okay, to figure out what is the height of the top of that rock formation, which we're looking for here, we need to know what this is, and we need to know what this is. So I'm going to call this H2 and this guy here H1. Okay. So in order for us to do that, oh, and I'm going to call this guy here x, we need to know all three of those things, x, h1, and h2. So x can be found by using, since x is equivalent to this x, and that's adjacent to 10 degrees, I can say cosine of 10 degrees is x over 100. So therefore x is 100 cosine of 10. So once I know that, I can then figure out what is h2. So h2 over x is equivalent to tangent of 22. So h2 is equal to x times tangent of 22. So let's punch this into the calculator. What was x? 100 times cosine 10. And that would be 98.48. h2, therefore, is equal to that times tangent 22 times 98.48. That would be 39.8. And I need to figure out what is h1 because I need to know the full height of the rock formation. So h1 over x, because this guy here is also h1, right, is equal to, h1 over 100 is equal to sine of 10 degrees. So h1 is equal to 100 sine of 10. And what would that be? 100 sine of 10, 17.36. If I add 17.36 with the 39.8 there, the height, so the height of rock formation is equivalent to h1 plus h2, which is going to be 17.36 plus 39.8, or 17.36 plus 39.78, right, is equal to 57.14. 57.14 feet. And there you go.